Good morning. Today we are going to cover section 9.4, graphs of other circular functions. Go ahead and take the time to copy your title and your essential question. How do you sketch the graphs of other trigonometric functions? Go ahead and copy down your graphs, your tables, and two other graphs. One to be able to graph the basic tangent and the other one to graph the basic cotangent. Go ahead and pause it and we'll continue once you're ready. So we're going to graph the basic tangent the same way that we graphed sine and cosine. We are going to use our unit circle and we're going to create a table of values. We're going to plug in values for x in radians and we'll get back values for y. And we'll translate that into a graph where this is your x-axis and this will be in radians. So 1, 2, 3, 4 will be pi. 1, 2, 3, 4 will be negative pi. This is pi over 2, pi over 4, 3 pi over 4, and negative pi over 4, negative 1 pi over 2, negative 3 pi over 4, and negative pi. On my y-axis will be 1, 2, 3, negative 1, negative 2, negative 3, negative 4. And now we are going to plug in values for x in radians. So therefore we're going to start with 0. I'm going to plug in a 0. And on unit circle, we know that this location of the point is 1, 0. And for tangent, tangent is y over x. So therefore, will be 0 over 1. 0 is y, 1 is x, which is 0. So therefore, my first point is at 0, 0. Next, instead of plugging pi over 2, I'm actually going to plug in pi over 4. Because that's going to give us a nice number. For pi over 4, since it's y over x, we know that the y is square root of 2 over 2, and your x is square root of 2 over 2, which will give us 1. So pi over 4 the square root of 2 over 2 divided by square root of 2 over 2 will give us 1. So this is pi over 4 will give us 1. At pi over 2, the location of this point is 0, 1. So therefore pi over 2 is y over x, so it'll be 1 over 0, which is undefined. That's going to create an asymptote. The same way that we've seen in other graphs, rational expressions. That's going to create our asymptote. And now we can continue to 3 pi over 4. But at 3 pi over 4, it's actually going to give us another part of the graph, which will be the y over the x. The y is square root of 2 over 2, and the x is negative square root of 2 over 2, which is negative 1. And if we continue to pi, which is at negative 1, 0, that will be 0 over negative 1, y over x, which is 0. So therefore, we're going to continue over to the left. We are going to continue to negative pi over 4, which is here. And your y value is negative square root 2 over 2. Your x value is positive square root 2 over 2. So therefore, a negative pi over 4 will give us a negative 1. Next, we're going to plug in a negative pi over 2. A negative pi over 2 is 0, comma, negative 1. So therefore, it will be y over x, negative 1 over 0, which will also be undefined. So therefore, we have our other asymptote here. And the graph will look something like this. It's going to get closer and closer to your asymptote on this side, and it's going to get closer and closer to your asymptote on this side. And if we actually continue, the next number will be over here, 5 pi over 4, and your next asymptote will be here. And the graph continues to repeat over and over again, and your other graph will be here. And one of the things that you'll notice that if you graph into your calculator, if I type in it going to y, and I type in the tangent of x, close it, and I graph it. And one of the things that you want to do once you use your calculator, you want to go under zoom, and there should be trig zoom. I want to go down to number 7. And you'll see the graph repeating over and over and over and over again. So the section that we graphed is the one in the middle, but the actual graph repeats continuously throughout. Or not continuously, but it continues to repeat. We'll come back to tangent in a bit. So let's go and graph a few of the tangent. Let's go over some of the properties. Go and paste your cut, copy example number 1, and we'll start once you're ready. Go and pause it. So this is the standard form of a tangent function where we have your d, your a, your b, and your c in the same manner that we had it with sine and cosine. Where your period is pi over b. Instead of 2 pi over b, the graph for tangent repeats every pi. So therefore, it's pi over b. Notice that this is one rotation, one period, not one rotation. This will be one period for tangent. Tangent is an odd function. If you take the tangent of pi over 4, gives you 1. If you take the tangent of negative pi over 4, gives you negative 1. It's discontinuous because it breaks every odd pi over 2, negative pi over 2, and there are breaks throughout. So this non-continuous function is a discontinuous function. The letter C, once again, is going to be your horizontal shift, which we usually call a phase shift. Your D is going to move it up or down, will be a vertical translation. And your asymptotes of one cycle will be determined by the following formula. Bx equals to negative pi over 2, and bx equals to positive pi over 2. Those are your two asymptotes in one cycle. Example number 1. We need to be able to graph the following function over 2 periods. So we're going to start with the first number. The 3 will be your amplitude. Well, it's not called an amplitude, but I'm just going to, for purposes, we'll put it into quotation marks because it's no longer called the amplitude. It's 3. Then the 2 is your B. That'll be your period. Your period now is pi over B. In this case, will be pi over 2. That means that a full cycle, the length will be pi over 2. And now we can start graphing it. When I make my graph for tangent, I prefer to make it more longer for the y-axis. And I need two periods, so therefore I'm going to start here. I want to be able to leave some space on the left. And once again, 1, 2, 3, 4 will be pi. 1, 2, 3, 4 will be 2 pi. 1, 2, 3, 4 will be 3 pi. To the left, 1, 2, 3, 4 will be negative pi. In order to graph it, I need to be able to find my asymptotes. My asymptotes are found where before we were using our period, now we are going to be using our asymptotes to be able to graph it. Will be bx equals will be negative pi over 2 and positive pi over 2. But in this case, our value of b is 2. So we're going to replace it with a 2. It's 2. Now I'm going to solve for x. I can divide by 2 or I can multiply by 1/2. Either way is fine. The 2's cancel, so therefore I have x is equal to negative pi over 4. That'll be my first asymptote. I can divide by 2 or I can multiply by 1/2. My 2's cancel, so therefore x is equal to pi over 4. So one of my asymptotes will be negative pi over 4, which is here. Then I'm going to draw. My other asymptotes are pi over 4. And now I'm going to highlight my period will be from one to another, and my period should match, and it does, right? Pi over 2 is 2 squares, so therefore that is the 2 squares, which is my period. And we're going to go through the same process. We're going to divide by in 4. I'm going to take half, half, and half. So now I'm going to start, notice that we're going to start on the bottom part. 3, negative 3, 0, and then positive 3. Since my amplitude is 3, it will be 1, 2, 3, 0, and positive 3. Notice that by the 3 basically got stretched by a factor of 3. And now I can sketch my first, comes from here, it curves a little bit, and then curves back. And it's going to follow the asymptote all the way through. And now I need to do another period. I can go through a process and add pi over 2 to this asymptote. 1/4 plus 1/2 will be 3/4. Or I can just say, you know, my next my period is pi over 2, which is 2 squares, so I can just go 2 squares. And that'll be my next asymptote. Or if you actually want to be able to find the location, just add your period, which is pi over 2. Pi over 4 plus pi over 2 is 3/4, which is located here. And once again, I'm going to divide it into 4 sections. And I'm going to start at negative 3, 0, and positive 3. And that'll be my next rotation. And then if I need to do another one, then I can continue, gain 2 more squares, which is pi over 2, get my next. And if we graph it, place 3 and insert a 2, that'll be your graph. In this case, we only did 2 rotations, so it looks slightly different. Next, my domain and my range. My domain is going to be all real numbers except for, and we're going to write down in the different form, because otherwise we're going to have to write down every single interval. So we're going to say all real numbers except when x is equal to, and I'm going to just pick one of my asymptotes. I'm going to pick the positive one, which is pi over 4, pi over 4, and it repeats every pi over 2 because that's my period. And I'm going to place in n as the variable, where n is any positive integer. I'm just going to write down past integer. And that'll be the notation for your domain. Your range will be all real numbers, or from negative infinity to positive infinity. But this is the equation for your domain. It's going to be all real numbers except for every time they happens to be in asymptote. Example number 2. Go and copy it down, and we'll start once you are ready. Go and pause it. So the 2 will be our amplitude. It's not really an amplitude, but we'll call it an amplitude just to make our process a little easier. For your period, there's a 1. So therefore, for your period, remember, for tangent is pi over b, where b in this case is 1. So therefore, that'll be only pi. So every 4 squares will be 1 period. Next, this is going to be your phase shift. It's your horizontal shift, but we now call it a phase shift. And it's negative, so therefore it's going to shift to the right. There's no vertical shift. And now your asymptotes. Your asymptotes are going to be x equal to negative pi over 2 and x equal to positive pi over 2. And then let's not forget the b. But in this case, b is 1. So those are your 2 asymptotes. So let's go and start building, and then we can talk about your phase shift. I need from negative 2 pi to 2 pi. So 2, 4, 6, 8. This should be sufficient. No vertical shift, so I can just place my x-axis here. So 2, 4 will be pi. 2, 4 will be 2 pi. Negative pi. Negative 2 pi. So right now, if I was going to draw my asymptotes will be from negative pi over 2 to to positive pi over 2. But now they will be shifted. They will be shifted to the right pi over 2. So this, my period is pi, which should match because that's 4 squares. But I'm going to be shifting it to the right pi over 2, which is 2 squares. So therefore now it will be over here. So it's supposed to be here, but because I'm shifting it to the right pi over 2, I'm going to have to shift it here. So one of the best things to do is to be able to just add your shift. I'm going to add it to each of my asymptotes. I'm just going to add it to pi over 2 into negative pi over 2. So therefore my asymptote is now going to be 0. And my other asymptote will be pi over 2 plus pi over 2 will be pi. My asymptote is now pi and 0. So here's 4, 0. And here's 4 pi. Right? It used to be here, but now I got shifted to the right pi over 2. And now I'm going to go through the same process. I'm going to highlight my period, should match my period, and it does. I'm going to divide it into 4 sections, half, half, and half. And I'm going to start at negative 2. Then 0, and then positive 2, and that will be my graph. It's going to follow your asymptote all the way through. Now I need to be able to build all the way from negative 2 pi to 2 pi, so therefore I'm going to do another period. Well, I know my period is pi, so which is 4 squares, so therefore 1, 2, 3, 4. So my other asymptote should be at 2 pi. I'm going to divide in half, divide in half, divide in half. Will be from negative 2, 0 to positive 2. And that'll be my other. Now on the left, I'll place another period, which is pi. So therefore my 1, 2, 3, 4. My other asymptote should be at negative pi. I'm going to divide in half, divide in half, and divide in half. Then it will be negative 2, 0, positive 2. And I can fit one more here. So it'll be 4 squares, since that's the period. Therefore, I'm going to place my last asymptote. I'm going to divide in half, half, half. Negative 2, 0, positive 2. And the last thing I need to do is my domain and range. My range is over a number. My domain, it's all real numbers except for when x is equal to, I'm going to select one of my asymptotes. I'm going to select 0. Or you can select pi if you want. Then half and does a repeat. My period is pi. And Now, when we usually have a 0, we actually don't include the 0. So most of the time you guys will see it as except when pi. So every where n is in real, is an integer. A positive or it's actually just an integer. I know in the last one I said it was a positive integer, but it can also be a negative integer as well. So let me just get rid of any integer. If we can fix this, will be great. Because it can also be, if you plug in a negative, it will give you this, negative pi, negative 2 pi. And those are the graphs for tangent. Now let's go back to building your cotangent graph. For cotangent, we're going to go through the same process. X and Y. And now remember that cotangent is the reciprocal of tangent. So we're going to use this to be able to build our graph. I'll plug it in 0. When we plug it in 0, it gives us 0 over 1. So now it'll be, the reciprocal will be 1 over 0, which makes it into a undefined. So that will create an asymptote. Now for pi over 4, so 1, 2, 3, 4 is pi. Pi over 4 is here. Is 1. The reciprocal of 1 is also 1. So pi over 4, it'll give us a 1. Then at pi over 2, it was 1 over 0. The reciprocal of 1 over 0 is 0 over 1, which is 0. At 3 pi over 4, the reciprocal is negative 1. Or negative 1 is negative 1 as well. At pi, it was 0 over negative 1. The reciprocal is negative 1 over 0, which makes it undefined. So therefore at pi, we have our other asymptote. So this is the graph of a cotangent. Coming down. Fix up those 2 points and then gets closer and closer to your asymptote on both sides. And then you'll repeat once again. So if I graph cotangent on my graphing calculator. Now, this does not have a cotangent key, so how can we graph cotangent? It will be fraction bar 1 over the tangent of x. And that is the graph. Where that is pi. So let's go through example number 3. So before, go and paste your cutout, copy example number 3, and then we'll start once you're ready. So in this case, once again, we have D, which will be your vertical translation, moves up or down your graph. Your A will be your amplitude. Your B is pi of your period. Notice that your period, once again, is going to be pi over B, where your sine and cosine needs to be 2 pi over B. Your C is your horizontal translation, which we call our phase shift. It's an odd function. That means if we plug in a pi over 4, will give us a 1. And the cotangent of negative power 4 will give us -1. And the graph is discontinuous because of due to the asymptotes. Your asymptotes are going to be slightly different. For your asymptotes, the equation is bx is equal to 0 and bx equal to pi. Where on your tangent, your asymptotes were at negative power 2 and positive power 2. Now your asymptotes are at 0 and pi. So let's go and graph the first equation. Graph over 2 periods. First, your 3 is your amplitude. We're going to place it in quotation marks. It's not really called the amplitude, but we're going to use the same terminology as when we graph sine and cosine. It's 3. Remember, it's always going to be the absolute value. Then the 4, that'll be pi of your period. So therefore, it'll be pi over, not 4, but 1 over 4. Right? We want to be able to think about it as the cotangent of 1 over 4x. Same thing. So therefore, your period will be 4 pi. And we need to be able to graph 2 periods. Next, I need to be able to find my asymptotes. Will b equal to 0 and b equal to x. That'll be, this is x equal to 0 and x equal to pi. So x equal to 0 and x equal to pi with my b on the front. In this case, your b is 1/4. So therefore, to solve for x, I'm going to multiply both sides by 4. So it gives us x equal to 0 is my first asymptote. I'm going to multiply both sides by 4. So therefore, x equal to 4 pi will be my second asymptote. And I need 2 periods, so therefore I need 8 pi's. So 2, 4, 6, 8, 10, 12, 14, 16. I'm just going to make one on the right and one on the left. So I want 2, 4, 6, 8. This should be good. So just make sure I have 8 squares on the right. And it's not shifting up or down, so I'm just going to place it here. So 1, 2, 3, 4. Actually, I need 4 pi for one period, so this will be 1 pi, 2 pi, 3 pi, and 4 pi. So the last will be negative pi, negative 2 pi, negative 3 pi, and negative 4 pi. My first asymptote will be at 0. There's no horizontal shift. So I can take care of my asymptotes right away. So therefore, I took care of my asymptotes, and this period should match 4 pi, and it does. I'm going to divide it in 4 sections, and half, it's already in 4 sections. My cotangent goes something like this. So it'll be 3, 0, and negative 3. And therefore, it's going to come down from here. Go pick up those 2 points, those 3 points, and come back down. And I need 2 periods, so I'm going to make another period on the left-hand side. The period is 4 pi, so I'm going to highlight 4 pi on the left. I'm going to place my asymptote. I'm going to divide in 4 sections. It's already divided, so it'll be 3, 0, -3. I come down from here, pick up those points, and come back there. Next, my domain and range. My domain is going to be all real numbers. Except when x is equal to, I'm going to select one of my asymptotes, which will be 0, plus my period, which is half and as a repeat, 4 pi n. And just like we mentioned before, we actually don't need that 0, where n is an integer. We don't want it to be a decimal, because that's not half is going to be repeated. So if you plug in a 0, you end up with this asymptote. Plug in a 1, you end up with this asymptote. You plug in a -1, you end up with this asymptote. You plug in a -2, will be -8 pi, which will be your other asymptote. And in each of those values, it's undefined. Your range will be all real numbers. And that is the graph of cotangent. Very similar to tangent, but you want to be able to visualize your graphs. That's cotangent. This is tangent. Example number 4. Last example for today. So go ahead and pause it, see if you can graph it, and then we can check and see if you did it correctly. Go and pause it. So one of the things that you should notice is that we need to be able to take out the 2, factor out the 2. So therefore we have y equals 1 minus 2 cotangent on factorial 2. What's left behind? We have x plus pi over 2, correct. And then I usually start from the left to the right. The 1 is going to be your vertical shift. Your vertical translation, which is +1. The -2, so that is going to be reflected on the x-axis. The 2 is going to be your amplitude. That 2 is your b, will be pi of your period. It's not 2 pi, but it's pi over b. Remember, for sine and cosine is 2 pi. For tangent and cotangent is pi over b, which is 2. And the pi over 2 will be shifted to the left. We call that a phase shift. And now my asymptotes. Will be x equal to 0 and x equal to pi for cotangent. But let's not forget OB, which is 2. We're going to divide by 2, so therefore x equal to 0. Divide by 2, so therefore x equal to pi over 2. And we need to fill out the entire interval from -2 pi to pi, to 2 pi. Up here is half a pi, so therefore we should have 1, 2, 3, 4, 5, 6, 7, 8. Correct? So I'll make sure that I have 8 squares on the left, 2, 4, 6, 8. 2, 4, 6, 8. So this should be a good center. Is being shifted up 1, so I need a little more space on top. I'll place it. This should be fine. Just one space. So let me go and label it. 1, 2, 3, 4 is pi. 1, 2, 3, 4 is 2 pi. Negative pi. Negative 2 pi. Then 1, 2, 3, and so on. So how do we start? We start by building our asymptotes, which are 0 and pi over 2, but we do need to shift it. So therefore, we're going to take our asymptote. Remember that this at 0 and pi over 2. So at 0 is to be here, and at pi over 2, which is here. That should have been my but it will be shifted to the left pi over 2, which is 2 squares. So now it'll be over here. Now the best thing to do is to actually just take your phase shift and add it to both. In this case, minus pi over 2 minus pi over 2. So therefore my asymptote will be x equal to negative pi over 2 and x equal to 0. 0 is still one of my asymptotes. Negative pi over 2 is here. Let's see. Vertical shift. I need to shift it up one, so therefore I need to make my new x-axis or my new midline at 1. My amplitude is 2, so I'm going to go all the way up to 3 and all the way down to negative 1. My period will be taken care of by my asymptotes, which I already took care of it, and I already took care of my shift. So therefore, I'm going to highlight on my midline my period, which is 2 squares, which is pi over 2. I'm going to divide it in 4 sections. And our cotangent looks something like this. But it's reflect on the x-axis. So instead of starting here, I must start down here. So it's going to look like a tangent. And that'll be my graph. And now I need to be able to do it over the interval. So therefore my period is pi over 2. So I'll take another pi over 2, which is 2 squares. And that'll be my next asymptote. I'm going to divide in 4 sections. Even though cotangent is reflected, so I'm going to start from negative 1, 0 to positive 3. Once again, I'm going to take my period, which is pi over 2, which is 2 squares, and that'll be my next asymptote. And I'm just going to fill up my entire space with cotangent graphs that are reflected. We'll take another. Cut it in 4 sections. Last thing that we need to do is to be able to find your dominant range. So that'll be I'm just going to graph them all. And the last one. Having 4 sections. A little messy. I do need to be able to see the information on the left-hand side. I need to be able to see that you added your phase shift to your asymptotes, to be able to locate your new asymptotes. I need to be able to see your points when you graph it. Otherwise, you will not be able to get any credit. You get 0. And let me just build the last one. And that's it. One more. Last thing will be your domain and range. Your domain, well, your range is all real numbers. Your domain will be all real numbers except for when x is equal to, you just need to select one of them. I want to select 0. And then I'm not going to place a 0. I'm just going to place my period, which is pi over 2n, where n is any integer. And that will conclude the lesson for today. Have a great day, and I'll see you next time.